what we have for today. So we'll go ahead to what we have for today. So today we'll be talking about the logistic regressions. The logistics regression. So we have three types that we'll talk about. We have the binomial logistic, we have the nominal logistic, and we have the multinomial logistic. Now, when do we use the logistic regression? So the first regression I taught, which is ordinary least square regression, the dependent variable is a continuous data. Is a continuous data. But in a case when it's a categorical data, so for OLX, the dependent variable is a quantitative data. So what if it is a qualitative? That means it is a categorical or is a string data. So what do you do? Like what I mean is if the dependent variable is talking about gender, in gender we have male and female, or it's talking about rank of officers, we have junior staff and senior staff, or it's talking about these courses you offer in the university, Mass 101, Star 101, Physics 101. So in those cases, the dependent variable is not a quantitative data. So what will you do? You can no longer use OLS. So you have to consider the multinomial logistic regression or the binary logistic regression or the ordinal logistic regression. So we use the different logistic regression when the dependent variable is a categorical variable. That being said, now let's try to differentiate between the three of them. For binary logistic, if the dependent variable has only two levels, what I mean by two levels, we have male and female. If we are talking about gender, male and female, we have two levels. Or we are talking about high and low, two levels. We are talking about black and white, two levels. We are talking about go or come, two levels. So in these cases, we use binary logistic. Now, let me talk about ordinal and multinomial. If the dependent variable has more than two levels, you can either use multinomial or ordinal. More than two levels, you use multinomial or ordinal. So now, when do you use multinomial and when do you use multinomial and when do you use ordinal? You use the multinomial if the dependent variable, the levels cannot be ordered. If you cannot order them, if you cannot rank them, if you cannot say this one is greater than the other one, then you use the word multinomial. But if you can order them, you use the word ordinal. If you can order them, you use the word ordinal. If you cannot order them, you use the multinomial. Now, let me give you an example. If you're talking about if the dependent variable is the courses you offer in the university, you cannot order that one. You cannot order, you can't tell me just 103 is better than just 101 or Mass 101 is better than this 101. So you cannot order them. In such situation where you cannot order them, you use multinomial. But when you are talking about the rank of lecturers in your department, you can order them. You know that lecturer 1 is higher than lecturer 2. Lecturer 2 is higher than assistant lecturer is higher than graduate assistant. Professor is higher than associate professor. So when you can order the rank, yes, they are not quantitative variables. That means you can use logistic and you can order it. So we use ordinal logistic regression. So in summary, we use binary logistic when the two variables, the dependent variable has two levels. We use multinomial and ordinal when it has more than two levels. We use multinomial when you cannot order the levels, and we use ordinal when you can order the levels. Very simple. So now, having explained the differences between the three of them, we can now start with the binary logistic regression. So I can go back to sharing my screen. So we can go back to, let me go to my desktop analysis. So let's start with the binary logistic. So now in binary logistic, forget about whether you can order them or not. It's not, as far as it has only two levels, you still use binary logistic. So we don't really consider whether you can order them or not, as far as it has two levels. Now, for binary logistics, you have to know the variable that you are. So I'm using SPSS. You have to know the variable that is of interest to you, like the level that is of interest to you. I've told you that you will have two levels. So in this case, what we are using as our dependent variable is collateral. So this is a microfinance bank. They are trying to get a model that they want to, when they consider various factors, they will be able to know. Okay, sorry, the dependent variable here is status. They want to consider various factors so that when they know when you come to take a loan, they will know whether you will default in paying the loan or not. So if they know that if they input your variable, your covariate, your factors, your features into the model will tell them that this person is likely to default in paying. And the model can also tell them how likely you are to default in paying. So if they discover that the likeliness of you defaulting in paying is very high, they can decide not to give you the loan. But if they discover that you are more likely to repay the loan, they will give you the loan. So you see how important this model is. You won't even know when they are applying it. They will just apply it and use it. So you won't know when they are applying it. Now, in this case, you are, like I said, you have to know the one that is of interest to you. So what is of interest to us is if it is what, let me see what one is. One is default. So you use what is of interest. Default is of interest to us. That's why default is one. We use one question and they are coded. So default is of interest to us. So what's of interest? The particular level that is of as one. Santos.
Yes, sir.
Can you hear me?
Yes, sir. Good afternoon, sir.
Yeah, good afternoon. So I've been the only one in the class talking to myself. Okay,
Sorry.
no problem. So I'm talking about binary logistic regression now. So this is how we do it. And we use it when the dependent variable is a categorical data. That means they are not numbers, they are categorical data. So in this case, and when they have only two levels, so maybe later you check I've already explained it in detail. So when you go through the video, you understand. But just how do we do the analysis? We go to analyze, we go to regression, then we go to binary logistics, analyze, regression, binary logistics. Then yeah, you put your dependent variable. Our dependent variable is status. Our independent variable, yeah, the amount the individual wants to borrow. So what this example we are trying to do is we are trying to get a model. A microfinance bank, they want to get a model so that when you come to take a loan from their bank, they will just ask you few questions. When they ask you the few questions, they will input it into the model. And the model will be able to tell them if this person is likely to pay the loan or the person is likely to default in paying the loan. That's how important it is. So these are all the things we need. When you are done, you go to category and you move. Look at this now. Look at this. Amount is a quantitative data. It's not a categorical data. You don't move it here. Look, let me show you what I went to. You go to categorical, move all the categorical variables there also. So the amount is a numerical data, so you don't move it. Period is a categorical data, so you move it. Collateral is a categorical data, you move it. Another loan, look at it, is a categorical data, yes or no, so you move it. Recipient is a categorical data, you also move it. So the only one you're not going to move here is amount. Why are we not going to move it? Because what? Numbers. Wait, I'm coming in a minute. So I've gone to categorical. So next you go to option. You click Sometimes I click this, sometimes I just click. So let's see. That's all. So you click OK, then your result will come out. So now let me explain this result briefly. This is just telling you if you have missing value, so not really important. It just tell you if you have missing value or not. Then this will tell you what you are using as 0 and what you are using as 1. Remember, I told you what you want your interpretation to be on, to be used as 1. So I'm not going to use this. So this is when the model doesn't have the parameters, the variables you are considering. The model only has the intercept. That's the only, when the model has only intercept. What I mean by intercept in regression, I'm talking about the B naught. When the model has only B naught without the X1 and B1, X2, B2 to XMDN, that means all the variables that we are considering, the variables we are considering, what? Amount, period, collateral, another loan recipient. We are using all this to model if the person will default in repaying the loan. So when the model doesn't have all these variables, it only have the intercept or constant. This will be the result. That means the accuracy will be what? 64. So what do we use this to know? We use this to know if the variables, they are contributing. If the variables, all these variables, they are contributing in predicting the status of the loan. So normally, when the variables are not in the model, the accuracy should be low. So if we include all the variables in the model and the accuracy is not higher than this, means all the variables that we are considering are wrong. That means we can't predict if the patient will default in repaying the loan with those variables. So now we are expecting that the accuracy of the model, when we include all the variables, should be higher than 64. So this table means what? Only the constant is in the model. Look at it again. Variable in the equation. The only variable we have here is what? The constant. Variables not in the equation. None of them were included. So now, this is when the variables were entered. We use this chi-square to test. Remember, when we did OLS model, we tested for the significance of the model. So this test here is used to know this test, omnibus test of model coefficient, is used to test the significance of the model. The same thing we did in ordinary least square regression. I will show you a complete work. I'm just trying to explain all the results so that when I show you the complete work, you know how I got it. In this case, this is just like your normal arrow square, though we call it pseudo arrow square, but it's similar. It's trying to imitate the normal arrow square that I explained in OLS regression. So the one it has, so the SPSS gave us two different types of pseudo arrow square. The first one, which is the cos and Snell, and this other second one. So you can use any of them. I think I mostly use the last one. We'll come back to this. So we don't use this. We'll delete it. This is now telling us the accuracy of the model after including all the variables. What's the accuracy? The accuracy is 86.5. Before including the variable, what's the accuracy? 64. So that means adding the variables assisted us in predicting whether a customer, a client, will default in repaying the loan. So this is telling us that the model is 86% accurate or it's 7% accurate. That means you can use the model to predict whether a client will default in repaying the loan. Then is the regression coefficient. And this will use the significance of it to know whether it's significant, the p-value to know whether it's significant or not. Then what we interpret mostly is this, the p-value, the regression coefficient b and the exponent of b. Now, it may look complex, but very simple. So let me show you a complete work I did based on the result from SPSS. Then the main thing that you need to learn here is how to interpret this final table. how to interpret this final table. This final table, that's the main thing. Then I will show you, look at this now, period. We have period, period, period. We have another loan. We have collateral. I will explain what these things mean. Now take notes. In period, we coded it 0, 1, 2. 0, 1, 2. Let me show you. You have to go back to your period. Or most times I have to go back to your period. Okay, look at it. Period 0, 1, 2. That's how we coded it. So 0 means 1 to 3 months, 1 means 3 to 6 months, and 2 means 1 to 6 months. Recipient 0 means individual, 1 means union. Collateral 0 means no collateral, 1 means collateral. So now look at what is happening here. Based on this table, it means, let me show you, let me start with period. It means you compare coded value of 1 for period against coded value of 0. Then you also compare coded value of 2 against coded value of 0. Look at what we compare 1 and 0, 2 and 0. Now, listen, let me explain something. When it has only 2 levels, when a variable has only 2 levels, SPSS will only bring out 1. But just know that even though it brought out only 1, that 1 is being compared to the first level. That means this level with 0 that you coded with 0. So look at this now, another loan. SPSS brought out only 1, another loan, then bracket 1. But what our SPSS is telling us that this another loan 1, another loan 1 means what? Another loan 1 means no. So no is being compared to yes. That's what arrow is doing. SPSS is doing. It's comparing no and yes. So when it has only 2 levels, SPSS will only bring out the last one. But just know that the result there you get, you compare it with, I will show you how to compare. You compare it with the first one. Recipient, SPSS will only bring 1. And don't just know that you are comparing 1 and 0. But for period that has 3 levels, SPSS will bring the 3. But even though SPSS brought the 3, for the first level, there will not be any result. Look at it. The first level, I see that here is empty. I see that here is empty. For the first level, yes. And why is it empty? Because this is used for comparison. It's used for comparison. The 2 is compared to it, and 1 is compared to it. So because we have more than 1, SPSS will bring out everything. But just know that 1 is compared to this and 2 is compared to this. Then I will teach you how to do this. So look at this result. Let me show you how I interpreted it. So look at it. I got a frequency table. So you have to get the frequency table yourself. I've taught you how to get N and percentage. Normally, you can do it using the descriptive statistics I taught you earlier. You can go to descriptive frequency and do it. But normally, what I used to do it is I prefer using multinomial logistics to do it. So I can do something like this, even though I'm not doing multinomial logistics. Status, I will just do something like this. Then I go to statistics. Okay, not this. Option. Okay, click OK. Let me see. So look at it. So if I do multinomial logistics, it will come out, the result comes out with a frequency. So I prefer using it. So I come to this, then I delete the missing value. I can delete this, can delete this, can even delete this. But you can also do this using your normal analyze, descriptive and frequency, which I have taught earlier. So back to this, back to what I'm interpreting. So I got frequency, which is not compulsory, it's your choice. Like when I do analysis for people, you are the analyst, you decide what and what to do in your results. So I interpreted that. Then I told you we have the pseudo arrow square. So this is where I interpret. So the dependent variable is a dichotomous. So I'm trying to explain why I'm using binary logistics. I've always told you, you're a data doctor. When you are prescribing a statistical method, always tell them why you are using that method, the reason. So the dependent variable is a dichotomous. Dichotomous means it has only 2 levels, dichotomous variable, and the independence of the quantitative variable. Okay, no. Okay, this is talking about assumption. One of the assumptions is a multicollinearity, but you only test multicollinearity when you have Majorly, you only test for SPSS, you test for multicollinearity when the independent variables are continuous variable. But in this case, we only have one continuous variable or one quantitative variable. So because we only have one quantitative variable, you can't test for multicollinearity. So that's what I'm trying to state here. But though some authors have proposed another method that can be used to do that, but we are not considering that in this class. So for now, we are saying that because we only have one, what's the quantitative variable here? The quantitative variable here is this. That's what we have. So because we only have one, we cannot do test for multicollinearity. So that's what I was stating here. So look at it. So therefore, the data is suitable for binary logistic regression. Okay, I think in this work, I made a mistake. I didn't tell them why I'm using binary logistic. I should have stated that the reason why I'm using binary logistic is because the dependent variable is a categorical data with two levels, or I say is a dichotomous categorical variable. So I would have stated is a that, and that is why I'm using binary logistic. So I didn't state it here, which is not proper. So correct that. Then I'm trying to, this is the goodness of fit of the model. So for goodness of fit, we are using the arrow square, the pseudo arrow square to know. So I interpreted the last one. So the variable, I've explained how to explain, I've taught you how to explain arrow square. So no need of, so look at it here again. So the approach of the linear is trying to mimic the normal arrow square that OLS uses. So it's used to know the percentage of variation explained. So relatively, we have 71.2% of the variation of the dependent variable, and the dependent variable here is what? Known status. That can be explained by the independent variable. So that's it. Then I told you that we use the chi-square to test for what? The goodness of fit of the model. The same thing with OLS. OLS does. So we reject. So in this case, the null hypothesis is that what? Is not significant. That means the model is not good. The alternative hypothesis is that the model is good. Now, how did SPSS get this value? SPSS got this value by comparing two models. What are the two models? The first model that was done with only the intercept that I've been trying to explain, only the intercept, and the other model that was done when all the variables, the independent variables, were added to the model. So SPSS is not, it's not your duty to learn how SPSS got the value, but I just want to tell you how the values we are gotten. So SPSS will combine this and this. And after combining it, so SPSS will give you the what? The chi-square statistic and the p-value. So that's also, we are rejecting the null hypothesis. It means the model is very good. And I've told you why the model is good. The accuracy increased after we added the regression coefficient. The accuracy increased. Then the next thing you explain, so the first thing you explain is, we talked about descriptive statistics, which your choice, you can decide to add it. You can also decide to add a graph if you want, like I selected a graph which came out. So if you want to add a graph, you add it. If you want to add a graph, you add it. Like that is your choice. So I didn't add it in this work. Then the last thing to interpret is the next thing to interpret is your table. This table. No. Okay, that graph is not for this multinomial logistics. So the next thing to interpret is this. Normally, some people can prefer to interpret this first before interpreting this. For me, whenever I'm doing my work, it's like I prefer interpreting this first before interpreting this. So let me teach you how to interpret this. This is where the main work is. So normally what I do is I normally change this 1 to the actual name. What is 1? What is 1? What is 2? So I normally change it. So look at this. Are you seeing that I changed it to know? So that it will help me to interpret. I can't be using 1 and 2 or 0 to interpret. I need to know what 1 means. So I normally change it. So compare what is here. Are you seeing 1, 1, 1, 1, 2, and compare what is here? I've changed it. So what we interpret is this and this. Then we use this to know whether we interpret it or not. We only interpret it when it is significant. When it is not significant, we don't interpret it. So what I mean is, let me see what we are using as level of significance. Level of significance is 0.05. So it means we are not going to interpret this. Why are we not going to interpret it? It is what? That we are not going to explain what this means. what the B means and what this exponent B means, we are going to say that it's not significant. That's the only interpretation we are going to give for this. We are going to interpret another loan. We are going to interpret collateral. We are not going to interpret period. Why we are not going to interpret period is because what? The p-value is greater than 0.05. So we'll just tell them period is not significant. We are not going to interpret recipient. We are going to tell them recipient is not significant. So the only variables that we are going to interpret are another loan and what? Collateral. These are the two variables we interpret in details. Now, how do we interpret them? Very important. So I use bullet points here in this work so that I will take each of the variables and use the bullet point to explain them. So the first, I'm coming. Okay. So, like I said, you have to explain each of the variables here one after the other. So you pick one and explain. I was the one that designed the table this way. It didn't come, and I told you I changed 0, 1. I changed what they mean. So you be the one to do that. So look at our so the first one is what? Repayment of, the repayment period. So we are talking about period. So the first variable I interpreted there is period. I told you it's not significant. That's the only thing we tell them. So the repayment period of the loan has no significant effect in a client defaulting. Remember, I told you what you will select as 1 in your dependent variable is what your interpretation will be on. So because 1 in my dependent variable means default, 1 means default. So all the interpretation will be on default, not on default. In my interpretation, you will not see anything like non-default. So look at it. Look at it. 1 means default. So all my interpretation will be default. You will not see anything on non-default. But all you know that I'm trying to compare default and non-default. So anything I want to explain, I will be on default. So anything you want. So what you want your interpretation to be on, that's what you use as 1. So look at what we enter. So the repayment period, that is this period, all the 3. So they have no significant effect. They don't really determine whether the client will default in repaying the loan. And the reason is because the p-values are all greater than our level of significance. So are all greater than the level of significance. So that's all. So look at what we do. I remember I told you we'll compare 1 and 6 months to this. We also compare 3 to 6 months to this. So it means if you compare those that would choose between 1 to 6 months as the period that they want to take the loan, and you compare them with those that will choose 1 to 3 months, it means there will be no significant difference. The both of them, they will either default or not default. That means it doesn't affect whether they will default in repaying the loan. If you compare this and also to this, it won't change. So what is trying to say that the groups, all the groups, they behave similarly. They behave alike. Whether they will default or not, all of them behave alike. So the period of the loan has no effect. So that's all I interpreted there. So the second thing, the main interpretation is when it is significant. That's when you do the main interpretation. The next variable I interpreted is the recipient. Recipient is also not significant. So you will tell them whether the recipient is a union or an individual, it will not affect. So look at it. The recipient of the loan, whether an individual or a union, has no significant effect in a client defaulting or not in repaying the loan. And the reason is because what? P-value. When you compare both union and the individuals, the p-value is greater than what level of significance. You don't interpret it. You only tell them it's not significant and you stop there. So it means that whether it is a union coming to take the loan or whether it is an individual, both of them will behave alike. So this work, if example, they are not behaving alike, it means the work it would suggest that favor example. Now let's assume they are not behaving alike. That means the variable is significant. If it is significant, it means my recommendation would be I will compare both groups and look for the group that always defaults. So when I know the group that always default, I will now recommend to the microfinance company that this group, whenever they come, scrutinize them very well before you give them that loan. That because why? The risks or the odds for them to default is very high. So because it is very high, you have to scrutinize them very well. Then I will tell them focus more on union. That union, they tend not to default in repaying the loan. But based on this analysis, it's telling us that both union and individual, they behave alike. So because they behave alike, you don't have to favor a particular group. So that's what this work is saying. Do not favor the particular group. So now, if the variable is not significant, it means it's not important. It means you say the model is not good or you throw it away. No. What if it is not significant? It's trying to tell you that it's giving you a result that you must also interpret. It's trying to tell you that consider both groups equally. That's the interpretation. Consider both groups equally. Don't favor any group because both of them have this. They will behave alike. They behave. There is no difference in their behavior. The next variable I interpreted there is the amount they are going to take. So you check, is it significant? It's not also significant. So you state. So the amount has no significance. So whether they are taking 1 million or they are taking 10 million or they are taking 50 million, they will behave alike. And as the scriptures say, if you are faithful in little, you'll be faithful in much. If you are not faithful in little, you will not be faithful in much. So that's what this analysis is saying. But that doesn't mean that's the case always. In some companies, you may discover that people that are taking a smaller amount of loans may not default, while people that are taking higher amount may default. That one is still possible. But based on this analysis, it's telling us that whether they take small amount or they take a larger amount, they will still behave alike. So that's what the work is saying. And how do we know they will behave alike? It's because the p-value is greater than your level of significance. So the third variable I interpreted here is whether they will take another loan. So now let me show you how to interpret in details. So taking another loan is significant. So because it's significant, we interpret it. So let me show you before we read what is there. So you compare no with yes. So it means, look, we'll talk about no and yes. Then we'll talk about this b, and we'll talk about exponent of b. Now, because exponent of b is up to 80, is more than 2, I will take the inverse of it. Normally, I'm supposed to compare no against yes. But comparing no against yes, the value here is so high. So I will have to take the inverse. So taking the inverse means I will now compare yes against no. Follow me. Follow me. What I'm seeing now, what came out as my result is no against yes, which is the correct thing based on my result. But the value is so high, 80 is more than 2. Whenever it is more than 1, I always take the inverse. I don't like interpreting numbers that are more than 1. So whenever it is more than, the exponent of this more than 1, I like taking the inverse. So what I'm supposed, if you want to interpret based on this, you will do no against yes. But since it's so high, I will take the inverse. That means the reciprocal of this. And when I'm taking the reciprocal of this, I will now change this to yes against no. So that's what we'll do first. So let me interpret. So look at it. So taking another loan, that is yes. If you watch my interpretation, I didn't put the word yes. But what's the meaning of yes? Take another loan, yes, means I'm taking another loan. Take another loan, no, means I'm not taking another loan. So taking another loan, so it means I'm comparing yes versus no. Taking another loan significantly affects the repayment status, since the p-value of those that did not take another loan took another loan is less than what? This. Now, okay, what I interpreted here is that the taking another loan, whether you take or you don't take, it affects that's what I interpreted in the first section. So this is from the second section I took the reciprocal. So this first section I explained is just trying to tell us that whether you take a loan, whether you are going to take another loan, you have the mindset of taking another loan, or you don't have the mindset of taking another loan. That will affect whether you will repay or not. So that's the meaning of this. So now let's explain which group have a higher risk of defaulting. Is it those that have the tendency, the mindset that after this loan, they'll take another loan? Or is it those that do not have the mindset to take another loan? So that's what the second part will explain. So remember I told you we are going to take the inverse. So taking the inverse means we compare yes against no. So the odds of those that, okay, this first part I've not taken the inverse. This first part is from here I took the inverse, the last part. So when you want to interpret B, we call it odds. When you want to interpret B, we call it odds. When we want to interpret exponent of B, we talk about risk ratio, the risks or the likelihood. We talk about likelihood when we're talking about exponent of B. When we're talking about B, we talk about the odds. So for the odds now is what? Is 4 point. No. Wait, let me not make mistake. Now, sorry. So let me say it again. We use exponent of B to interpret. So based on this, if you compare no to yes, the odds is this. If you compare no against yes, the odds is this. Then when you want to, if I want to take the inverse, it means I'm comparing yes against no. So this thing means the odds of people that do not have the mindset of taking another loan, defaulting in repaying it, when compared to those that have the mindset of taking another loan, is 80.269. Let me say it again. Take note of the word defaulting. Is I won't use not default, I will use default. So let me repeat myself. The odds of those that will not default, that means I've talked about no, that will not default. I've talked about default. The odds of those that will not default, the odds of those that do not have the mindset of taking another loan, not defaulting, is 80.269 when compared to those that have the mindset of taking another loan. Let me say it again. The odds of those that do not have the mindset of taking another loan, defaulting, is 80.269 times the odds of those that have the mindset of taking another loan. So I've interpreted this. Then if I want to interpret it based on likelihood, I will then take the reciprocal. That's what I've been trying to say since. I will take the reciprocal. So when I take the reciprocal, it means I will also change it. Now, when I want to compare, I will compare yes against no. Now, the reason I prefer this, now, these two things are saying the same thing, using the odds to interpret it, or using the word, the likeliness to interpret it. Both of them mean the same thing. But I think this is like explaining it in a layman's language, that's so that anyone will understand. When you talk about odds, not everyone may understand what you are saying. So when I give this interpretation, I still go further to give this interpretation so that they will understand. Now, if I don't take the reciprocal always, the only time I take reciprocal is when this value, when I want to interpret based on the likeliness, the only time I take the reciprocal is when this value is more than 1 or 2. That's when I take. So when I take the reciprocal, I also take the reciprocal of this. So this is what it will be. Remember, I said we are comparing yes against no now. So those that took another loan, that means yes, are 1.25 less likely to default in repaying the loan. This is explained it in a layman's language. So looking at this, you understand that the people that are less likely to default in repaying the loan, they are what? Those that we take another loan, those that have the mindset of taking another loan. Then how did I get this 1.25? I took the reciprocal. That's all. Then how did I know that it is less likely? Sometimes it will be more likely. How did I know that it is less likely? How did I know it's less likely? Sometimes it may be more likely. So how did I know that it is less likely? After taking the reciprocal, the value here is less than 1. So because this value here is less than 1, it is less likely. If it is more than 1, it is more likely. It is less than 1, less likely. If it is more than 1, more likely. I think when we do that example, we'll see it. Then you multiply by 100, you get this. So those that took another loan are 1.25 less likely. If it was more than 1, it will now be more likely. That's being said. So let's go back to the next one. The next variable I interpreted is collateral. So if you want to interpret this, first of all, let's interpret it based on odds. When we want to interpret based on odds, it means you will use it the way it is. So you will compare yes against no. So listen carefully how I will interpret it before we read what is there. So you compare yes against no. So you will start with those that we give collateral, that is the meaning of yes. Those that will give collateral. Or you can start with saying that collateral significantly affects whether a client will default in repaying the loan because the p-value is less than the level of significance. So first, I've told them that the variable is significant. So you have to start by saying the variable is significant. So after telling us that the variable is significant, then you go further to explain in details the levels that are in the variable. So first, you tell us the variable, yes, they don't behave alike. All the people that, whether you give collateral or not, they don't behave alike. That's the first interpretation. You tell us they don't behave alike or they behave alike. So in this case, they don't behave alike. So since they don't behave alike, what is the next thing as they don't behave alike? You now compare yes against no. So listen carefully. I will against no. I will say those that, a minute, please. Okay. Okay. So we can continue. Santos, hope you can hear me.
Yes, sir.
Okay. Thank you. Okay. So now you compare yes against no. So let me look at it. So you will say the odds after telling us that the variable is significant. So you say the odds of those that gave collateral, that is meaning of yes, defaulting in repaying the loan is 29.065 times the odds of those that did not give collateral. Like I told you, giving the interpretation using the word odds may not be understood by everybody, but you have to also state it in statistical terms before interpreting it in a layman's term. So when we talk about the likeliness, we can interpret so that everyone can understand. When we are talking about the odds, that one we are speaking in statistical terms. So let me say it again. I'm interpreting this. So those that give collateral, or the odds of those that give collateral defaulting in repaying the loan is 29.05 times the odds of those that did not give collateral. So I compared yes against no, and my interest is on defaulting. So look at the odds. So now let me interpret it based on the likeliness. I will take the reciprocal of this. Why am I taking the reciprocal? It's because the number is too large. So taking the reciprocal, it means now I will compare no against yes. I will take the reciprocal of this also. So taking the reciprocal of 1/29 gave us this. So now my interpretation now will be no against yes. So that's the meaning of this second part. So those that did not give a collateral, that is no. Those that did not give collateral are 3.44% less likely to default. Why is it less likely? This number is less than 1. So that is why it is less likely. They are less likely to default in repaying the loan. If you can continue with this, when compared to those that gave collateral. Then the last thing, I will still show us another example. Then the last thing is the performance of the model. We talk about the performance of the model. All these are not important. Most times I just interpret only the percentage. You can only interpret the percentage, and that's all. If you want to read it, you read it, but the only thing I will teach here for this class is the interpret only the percentage. So that means, what's the percentage? It means the model is 86.5% accurate in predicting the right status of the client, defaulting or not in repaying the loan. Let me say it again. That means the model has an accuracy of 86.5% of reporting whether the client will default in repaying the loan or not. So let's try another example so that we can understand it better. There is another aspect I have not explained. So I think another example will give us. Let's see. Let me see this. No, not this. So I did frequency. This is frequency. Okay, the client asked for frequency and bar chart. So that's what I did the first part. So this is why I started this for binary logistics. Okay, no, this is for chi-square. Yeah, this is for binary logistics. This is for binary logistics. Okay, this is for binary logistics. So look at it. So the dependent variable is a dichotomous variable. We have two levels. That's why I'm using binary logistics. So you can complete it. So the dependent variable is a dichotomous variable. That is why we are using the binary logistic regression. Then I stated the independent variable for the model. Then the results of the different factors are given below. This is to check for the significance of the model. Then you also interpret the arrow square. I think for this work, I didn't interpret it because the client didn't want it. So I didn't interpret it. But you also interpret the arrow square. Then this is where the main work is. So first, you check if the variable is significant. So looking at this, remember I told you when you have three levels, it means you are comparing strongly agree and disagree. Then you are comparing agree and disagree. That means you compare the remaining levels with the first level. You compare the remaining levels with the first level. You can't compare, based on this work, you can't compare agree and strongly agree. No, you only compare this and this. You compare this and this. So if you compare strongly agree and disagree, you check the p-value. What's the p-value? It means they don't have any significant difference. Are we seeing it? Strongly agree and disagree. They don't have any significant difference. But agree and disagree have a significant difference. That's the meaning of this. Agree and disagree have a significant difference. Agree and disagree have a significant difference. That's the meaning of this. Then let's interpret this now without looking at the table. So first, we have to know what the dependent variable is. Then we know how to interpret it. The dependent variable here is what? HIV status. And I think one is positive. Is one negative? I don't know. Remember, I told you your interpretation will be on one. So I don't know if one in this work is positive or negative. But when we start interpreting, I will know whether it's positive or negative. So the dependent variable is HIV status. So I think one is positive. So now let's interpret this. Now we are interpreting this. So the odds of those that agree. Sorry, the odds of those that strongly agree and those that disagree that you can contract HIV/AIDS when you have oral sex without condom have no significant difference because what? The p-value is greater than 0.05. I've interpreted these two. So let me go to these two. The odds of those that agree when compared, or the odds of those that agree that oral sex without condom will make the patient or the subject to contract HIV when compared to those that disagree that oral sex without condom doesn't make the subject to contract HIV. Oh, no. So let me repeat it, please. The odds of those that agree that oral sex without condom will make the patient to contract HIV is, then you mentioned the odds, 0.225 times the odds of those that disagree. The odds of those that agree that having oral sex without condom will make you to contract HIV is 0.225 times those that disagree. Now, because the exponent of B is no more than 2, no more than 1, I can interpret it. I can interpret the likeliness using this. The likeliness using this. I don't need to take the inverse. Remember, we only took the inverse in the previous example I gave. Because what? The exponent of B is up to 2018 is more than 2. So now we have to interpret this. Now, how do we interpret this? The value of this is less than 1. So because it is less than 1, you know that it is less likely. It is less likely. Now to get the percentage, you do 1 minus this. 1 minus this. When you do 1 minus this, so look at it, 1 minus that, you then multiply by 100. That's to get the percentage. But you know that it is less likely. Why is it less likely? Because this number is less than 1. So let me read from here. First of all, you state that the variable is significant. So the opinion of having a high risk of contracting HIV when having oral sex without using condom contributes significantly. Because why? It contributes because why? This p-value is less than, the p-value of the variable that you are using to compare is less than 0.05. Now you start so the odds of those that agreed there is a high risk of contracting HIV when having oral sex without using condom, having a positive status is this. So first I interpreted it using the word odds. The second time I interpreted it using the word likelihood, the likelihood of contracting HIV. The two keywords there is likely, and the first one is what? Odds. So first interpret it based on odds, then interpret it based on what? Whether it is less likely or more likely. Why is it less likely? Because this number is less than 1. That's why it's less likely. And when it is less than 1, you do 1 minus to get the percentage. So this means that those that agreed, remember, you don't take the inverse now. So you compare agreed versus what? Disagreed. So those that agreed are what? 77.5% less likely to have a positive HIV status when compared to those that disagree. Then this is the other part that says there is no significant difference between the two groups. These disagree and strongly agree. Why? Because their p-value is greater than 0.05. It's very simple, though it looks complex. Then you go to the second variable, you interpret. The second variable, if you look at the second variable, it's telling us that this variable is significant. This variable is significant. That's why this p-value is less than 0.05. Even though it is significant, disagree and strongly agree are not significant. That means they behave alike. Agree and disagree, they also behave alike. So, but it's significant. Now, this thing means that if you compare this and this, they are similar. You compare this and this, they are similar. So it means that the difference may be between these two. But SPSS doesn't have the, it cannot test between both of them because why? You must have to select your reference level. So in this case, take note of that word. Reference level means that level that you compare the other levels with. Our reference level, is disagree. So we are comparing strongly agree with it and this and this. So we cannot compare the other levels. But these two, they behave similar, alike. These other two, they behave alike. But though the variable is significant, so that means it's likely that these two will not be behaving alike, but we can't test for it. So let me see what I interpreted there. So having total control. So that's it. Having total control in deciding whether to use condom when having oral sex without using condom contributes significantly because the p-value is what? Less than 0.05. The odds of those that agreed and strongly agreed have a positive do not differ significantly from those that disagree because of what? The p-value is greater than 0.05. That's it. Very simple. You interpret the next one. Now, in this case, it has only 2 levels. Because it has only 2 levels, that's why the second level is not showing. I've explained it earlier. When it has 2 levels, the two levels will not show. Only one will show. But if it has more than 2 levels, all of them will show. So this one it has 2 levels. That's why strongly agree is showing. So you have to know what is the reference level. The reference level will not show. So I think the reference level is disagree. So we are comparing strongly agree and disagree. So it is significant, so interpret it. And because the exponent of D is no more than 1, 2, is no more than 2. Because it's no more than 2, we are not going to take the inverse, so we interpret it the same way. So the use of lubricant with condom regularly during sexual intercourse contributes significantly to the HIV morbidity among these because why? The p-value is less. So I've explained, the first thing you explain is that it is significant. The next thing you explain using the odds. The third thing you explain using the what? Likelihood. How is it less likely or more likely? First, you tell us, is it significant or not? If it is significant, then you continue. Tell us about the odds and tell us about how likely it is. So I've explained, you explain using the odds. So because this number is less than 1, it is less than 1, I will take 1 minus this number to get the percentage. Then I will know it is less likely. Why is it less likely? It is less than 1. I'm looking for a number that is more than 1. So I will show you how to interpret it when it is more than 1. In this case, we are not going to interpret because all the p-values are greater than what? 0.05. So you just say easy access to healthcare doesn't affect whether they disagree or agree to this, doesn't affect. So that's the last part. So having an easy access to healthcare does not contribute significantly to HIV mobility among that. So now let me see if this has 1. I'm looking for a variable that will have 1 point. So I will show you how to interpret when it is 1 point. In this case, this variable is not significant. It's not significant. So the only variable here that is significant is this. So this is the only variable that is significant. In this case, none of them are significant. None. They are all not significant. In this case, they are all not significant. I'm looking for a variable that will have 1 so that I can teach you how to interpret when it is 1. So, okay, maybe since we don't have in binary logistic example, so when I want to teach you ordinal logistic, I will show you when it has 1, I will interpret it. So we are going to stop here for today. But let me just explain briefly. I don't know if you guys will get it, but if you don't get it, I will explain better when I want to explain ordinal multinomial. So assuming this thing is 1, assume this value is 1.275. Assume it is 1.275. How do you interpret it? First, you tell us that the variable is significant. Using lubricant with condom is significantly affect the HIV status, whether it will be positive or not. Those that strongly agree and those that disagree, it significantly affects. That means whether you are using lubricant with condom or you are not using it, it significantly affects. That means both of them are not behaving similarly. They don't behave alike. That's the first thing to interpret it. Next thing you interpret using the odds. Now, if you want to interpret using the odds, this is what it will be. Remember, we are comparing strongly agree and those that disagree. So I would say those that agree that the use of lubricant with condom will make the person to test positive to HIV. The odds is 1.275 when compared to those that disagree that use of lubricant with condom will make you test positive to HIV/AIDS. Now, I've interpreted it based on odds. So now let me interpret it based on the likelihood of having HIV/AIDS. Because it is 1 point, I'm assuming it's 1.275. What will you do? You will subtract one from it. So if you subtract 1 from it, it will now remain 0.275. Then you multiply by 100. It will now be 27.5%. Then because the number here is more than 1, it is now more likely. Then to get the percentage is 27.5. If it is more like when it is more than 1, it is more likely. When it is less than 1, it is what? Less likely. When it is more than 1, you subtract 1 from it to get the percentage. When you subtract 1, you multiply by 100 to get the percentage. So assume it is 1.275. You subtract 1 from it, you get what? 0.275. Multiply by 100, you get what? 27.5. So when you want to interpret based on the likelihood, the percentage there is 27.5%. So this is how I will interpret it. I would say those that strongly agree that the use of lubricant with condom will make the subject to test positive to HIV/AIDS. Okay, no, those. Let me state it again. Okay, those that strongly agree that they use lubricant with condom are 27.5% more likely to test positive to HIV/AIDS when compared to those that disagree. So the key word there is more more likely. And why is it more likely? Because it's 1.275 and the percentage is 27.5. So we're going to stop here for today. Now, just go through it. Look at my interpretation, master it. I've used 2 examples. Go through it, master it. But don't bother yourself. Now, when I want to explain multinomial and ordinal, you see the same, they behave alike. They are almost the same. The only difference is that multinomial, the levels are not ordered and they are more than 2. Ordinal, the levels are ordered. So, but when I'm talking about the odds, likelihood, that's what we are going to do, put in multinomial and ordinal. So just take your time and digest it. And this is very important because most work, they use this logistic regression. There's a particular article that I want to write with a senior colleague, and we are using both multinomial and ordinal logistic regression to talk about the variables that affect people in receiving COVID-19 vaccine. So I think that will be the end of today. So we are going to stop here for today. Thank you for joining us.